Alright, in this example I'm going to complete the square. I'm actually going to complete the square twice. Once with an equation, and once kind of in the general case to see what comes out of it. So let's see, to complete this square, we want a 1 as our leading coefficient. So we don't want this 2 out in front, so what we can do is divide both sides of the equation by 2. Make sure you divide everything on the left by 2, and you get x squared plus 3/2 x minus 5/2 equals 0 divided by 2, which is just 0. And I guess to do something similar over here, we divide both sides of the equation by a. So that would leave us with x squared plus b over a times x plus c over a is equal to 0 over a, which is just 0. Alright, now we can complete the square. Let's see, over here what we'll want is x plus half of this term here. So half of 3/2 is 3/4 squared. We'll still have this minus 5/2 over here equals 0. But what we have on the left here is not equal to what we have on the left here. If you expand this out, you'll end up with an extra plus 9/16. So what we have to do is subtract that extra 9/16 so that in fact we're equal to what we have up here. Alright, we can do something similar over here. X plus, we want half of this middle term here. So half of b over a is b over 2a squared. And we'll still have this c over a equals 0 out here. But again, what I have written on this line and this line aren't the same. If you expand this out, you'll end up with an extra b over 2a all squared. So what we got to do is subtract that b over 2a squared. Alright, let's see. Over on the left here, we could leave this guy alone, but maybe we'll find a common denominator for these guys. Let's see, 9/16 and 5/2. I guess the common denominator would be 16ths. So we'll get negative 9 over 16 minus 40 over 16 equals 0. And if we do something similar over here, we'll leave this guy alone. Then we have minus, see, b over 2a squared is b squared over 4a squared. 2a times 2a is 4a squared. And then we want the same denominator, 4a squared, over here. So let's see, we have a, we want 4a squared, so we'll multiply the top and the bottom by 4a. And get 4ac over 4a squared equals 0. Alright, moving on. Let's see, maybe we should move all this stuff to the right-hand side. X plus 3/4 squared. Negative 9/16 minus 40/16 is negative 49/16. So if we add 49/16 to both sides, we get to here. We can do something similar on this side. We'll leave this first term alone. Let's see, negative b squared plus 4ac all divided by 4a squared. So if we add that to the other side, we'll get positive b squared minus 4ac all over 4a squared. Alright, moving on. Now we want to solve for x, so let's take the square root of both sides. That leaves us with x plus 3/4 equals, when you take a square root, make sure you leave the plus or minus, the square root of 49 divided by 16. Over here, x plus b over 2a is equal to, take the square root of both sides, so we need the plus or minus, b squared minus 4ac over 4a squared. Alright, we're almost done. Over here we'll subtract 3/4 from both sides and get x equals negative 3/4 plus or minus, you can think of the square root of 49 over 16 as the square root of 49 divided by the square root of 16. But the square root of 16 is just 4. And over here, if you subtract b over 2a from both sides, see, on the top we got the square root of b squared minus 4ac. And kind of like we had over here, we can think of the bottom as the square root of 4a squared. But 4a squared is a perfect square, so we can just write that's equal to 2a and not put the square root on the bottom. And then I guess finally, if we combine these guys over their common denominator, we'd get negative 3 plus or minus square root of 49 over 4 on the left-hand side here. And on this side, we'd get negative b plus or minus the square root of b squared minus 4ac all over this common denominator of 2a. So maybe you're kind of impressed, maybe you're not, but what we came up with over here in the general case is exactly the quadratic equation. And if we had used this quadratic equation on an example here, we would have gotten these solutions right here. So there's a couple of examples of completing the square, and it shows where the quadratic equation comes from.